Welcome to Exponent Properties. The best way to use this video is to watch with your notebook and take notes while I'm teaching. This is part 1 of 2 videos, so please make sure to check out the second video after this. Pause the video often to get your notes down, and every time the video arrives at a "you try," pause, attempt each problem, and then press play to see the solutions along with my work. These are the topics we'll be covering in this video. We're going to begin with anatomy of a monomial. A monomial has 3 parts. The first part is a coefficient. The coefficient is the number in front of the base or variable. If you don't see a coefficient, the coefficient is 1. Next is the base. This can be a number or a variable. And then next is the exponent itself. So this is a monomial or a term. So if we take a look at 3x to the 5th power, 3 would be our coefficient, x would be our base, and 5 would be our exponent. When we look at y to the 4th, it looks like there isn't a coefficient, but there's actually a coefficient of 1, a base of y, and an exponent of 4. An exponent refers to the number of times a number is multiplied by itself. It's a shorthand. So instead of writing 3 times 3 times 3 times 3 times 3 5 times, we could say, okay, it's 3 5 times, so it's 3 to the 5th power. If we want to add and subtract monomials, when adding and subtracting monomials, we need to talk about like terms. Like terms have the same variables and exponents. The coefficients do not need to match. So let's take a look at 7y and 10y. The base is y, the exponent is 1, and the coefficients don't match, but that's okay, these are like terms. 5x and 2y do not have matching bases, so they are unlike. 2x to the 3rd, y to the 4th, and 5x to the 3rd, y to the 4th are like terms because their bases and exponents all match, where 3xy and 3x squared y are unlike terms. We cannot combine terms that are unlike. So when adding or subtracting, often called combining, like terms, we do not change the variables or exponents, the things that make them the same. We just add and subtract the coefficients. Let's take a look at a couple examples. For each problem, determine whether the terms are like, and if so, complete the operation. So first we need to take a look at the base. The base is x, the exponent's invisible, so it's a 1. So these terms are alike, which means we simply need to add, because there's an add, the coefficients. So it's going to be 7x. Remember, we don't change the x or x to the 1st. We simply add or subtract the coefficients. So first we determine if these are like terms, y to the 3rd and y to the 3rd. They are. Now we have to subtract the coefficients. It looks like there isn't a coefficient, so I'm going to put a 1. So really we're doing the operation 5 minus 1. So that would be 4y to the 3rd. Next we look at the example. We see that the bases are xy, xy. These are alike. So we're going to add 2 plus 7. We get 9xy. And finally, we look here. We have y to the 3rd and xy to the 3rd. These cannot be combined, so this is the final answer. You try these problems, press pause, and when you press play, the solutions will be on the next slide. Check your answers. Replay this part if you have any questions, and we're going to move on to multiplying monomials. When we're multiplying monomials, we're going to expand the exponents to see if we can find a pattern. So if we're given 3 to the 5th, we'll expand that to 3 5 times. And if we see 4 2's multiplied, we'll condense that to 2 to the 4th. When we're multiplying monomials, 3 to the 5th times 3 to the 2nd, what I did here is I expanded 3 to the 5th and times, so there's my times, 3 to the 2nd. Now if I were just to look at this right here, I could actually recondense it and say 1, 2, 3, 4, 5, 6, 7. So that's 3 to the 7th power. I can do the same thing here. That's 2 to the 3rd, so 2 3's. 2 to the 2nd, that's 2 2's. And then I can actually condense this back up, and I get 2 to the 5th. X to the 2nd times x to the 4th, expand it out, and then condense it back together, and I get x to the 6th. Now when I expand this out, 5 to the 3rd and 4 to the 2nd, I actually can't condense it anymore because these bases are not like, so they just stay exactly as they were. Now, see if you can see a shortcut. When we take a look at this, we can actually see a shortcut. So, if I look at the final exponent of 7, how did I get that from the exponents 5 and 2? I added. So if we look 2 to the third times 2 to the second, they have the same base of 2, and then I could add the exponents, and I would get the answer 2 to the fifth. Let's see if it works here. X has the same base, add the exponents, and I get x to the sixth. Now when I go to do it here, I can't because they don't have the same base, which is why this property didn't work. Let's take a look at some more examples. X to the third times x to the sixth. Because these have the same base, I can say x and add the exponents. When we multiply, we add the exponents. So our final answer is x to the ninth. Here we have the same base and we're multiplying. So the 5 stays because there's nothing to multiply that coefficient, and we add the exponents. So the final answer is 5y to the fifth. Here we have a little bit more complicated, so we got to break it down. We've got coefficients 2 and 7, so I'm going to multiply those just like regular numbers. I've got base x and base x, so that would be x. When I multiply the bases, I add the exponents. And I've got base y and base y. Now it looks like there's no exponent here, so I'm going to put a 1, so I don't forget that it's really 1 plus 2. My final answer would be 14 x to the sixth y to the third. Taking a look here, it looks like there's no coefficient. Remember, you can leave it as a 1 or just leave it alone. So we've got a base y and a base y here. So that's going to be y 4 plus 3 times x. Just going to rearrange it. We normally put the coefficient first and then do it in alphabetical order. So that's the final answer. Go ahead and give these examples a try. When you press play again, the solutions will be up. And see how you did. We're now going to move on to dividing monomials. When we talk about dividing monomials, we're going to do the same idea and expand them. So let's take a look at this slide here. If we've got 3 to the fifth and 3 to the second, they have the same base. So I'm going to expand out 3 5 times, and I'm going to expand out 3 2 times on the bottom. Well, we know that 3 over 3 is 1, so that goes away. 3 over 3 is 1. And that leaves me with 3 3's on the top. So the answer would be 3 to the third over 1, or 3 to the third, or 27. We look at dividing, we have the same base here. So on the top we have 3 2's, and on the bottom we have 2 2's. And we cross out what matches, because those are just 1. 2 over 2 is 1. And we get 2 to the first on the top, or just 2 over 1. Now here we have a little bit different. We've got 2 x's on the top and 4 x's on the bottom. So we have more x's on the bottom, so we know our answer is going to be on the bottom. We cross off x over x is 1, x over x is 1. Now be really careful here. These 2 x's are still on the bottom. They have to stay on the bottom. Now we can't just have floating denominators, so we put a 1 placeholder on top. Here we have a similar problem to earlier. 5 and 4 do not have the same base. So when I expand, there's nothing to cross out. So the answer just remains 5 to the third over 4 to the second. So do we see a shortcut? Let's take a peek and see if we can figure this one out. So if I look at 3 to the fifth and 3 to the second, I always say, okay, which exponent is bigger? The top is bigger, so I know that the base is going to stay on the top, and it does in fact stay in the top. Now how did I get from 5 and 2 to the exponent of 3? Well, I subtracted. So I said, okay, the bigger exponent is in the top, so my answer is going to be in the top. And 5 minus 2 gives me 3. So let's see if it works here. Which has a bigger exponent, the 3 or the 2? So the bigger exponent's in the top, so the 2 is going to be in the top. And I'm going to subtract 3 minus 2, and I get 2 to the first, or 2. Now here are the bigger exponents in the bottom, so I know that my answer is going to be in the bottom. I'm going to subtract. Now I can't just say that the answer here is x squared. It's in the bottom, so I have to put a 1 on top, and I do get it here. Because these are unlike bases, I can't simplify this anymore, so that trick doesn't work. Let's take a look at some more examples. Simplify each expression. So first we're going to check that the bases match. X to the 6th over x to the 3rd. That they are the same base. So then I look, okay, it's bigger in the top, so I know that the x is going in the top. Then I subtract, and I get x to the 3rd over 1, or just x to the 3rd. Remember, you have to have a numerator, but you don't have to have the 1 in the denominator. I've got a coefficient of 5, so there's nothing I can really do with that 5, so that's going to stay. The base y has a bigger exponent on the bottom, so the y goes on the bottom, and then I subtract the exponents. So I get 5 over y to the 1st, or just 5 over y. Remember that exponent of 1 doesn't need to be visible. Okay, I've got a lot going on here. So I'm going to make my pen size just a little bit smaller. So I've got coefficients 2 and 6 that I need to deal with. And now we deal with like regular fractions. They both have a common factor of 2. So I'll divide the 2 by 2 and I get 1. I divide the 6 by 2 and I get 3. Next I'm going to look at the x's. The bigger exponent's in the top, so it's x on top and then subtract the exponents. When I look at the y's here, I'm going to put a 1 so I don't forget it. And the y is bigger on the bottom, so I'm going to do 2 minus 1 on the bottom. So I get 1x to the 2nd over 3y to the 1st. Now remember that I don't need to really show this coefficient or that exponent of 1. So my final answer is just going to be x squared over 3y. But this is still right too. It's just you won't see that as an answer choice on a multiple choice or something. Okay, so we'll take a look here. There's nothing, the only thing to combine with are the y's. So the bigger exponent is on top, so the y will stay on the top, 4 minus 3. There's nothing to combine with the 3 and the x, so those stay. So we get y to the 1st over 3x, or just y over 3x. You try these examples, press play when you're ready to see the solutions, and see how you did. That concludes part 1 of exponent properties. Please make sure to check out part 2 in a separate video.